This is the first of 7 videos in a series about hypothesis testing. General concept. In order to give you a sense of what hypothesis testing is, which is essentially a statistical way to examine whether a claim is true or not, I want to start with a silly but meaningful example called the Guess Which Hand game. This is a game my daughters used to play. They would put an object in one of their hands, close their fists, hold out both, and say, "Dad, which hand is this in?" Well, I would win this game, as you might expect, about 50% of the time. But things changed when we started playing in the car. They knew I was driving and couldn't look back, and would say, "Dad, I'm holding something in one of my hands. Is it the left or the right?" I had to take their word for whether I had won, but strange thing, I didn't win this game very often. And this example will illustrate how statistics plays a role in hypothesis testing. The first thing we do when we want to test something is we make a claim. Now, my claim in this particular example was that the Guess Which Hand game, at least the car version of it, was rigged. The second thing we do in statistics is we gather data. So I played this game several times. In fact, I played 10 times, and it turns out I only won once. Big surprise. The third thing we do in hypothesis testing, in this context anyways, is I was going to assume that the game is fair. Now keep in mind, I'm thinking this game isn't fair, it's rigged, but to prove the point, I'm going to assume to the opposite, that the game is not rigged. In statistics, we call this the null hypothesis. It's the opposing statement to what it is that you're trying to prove. The alternative hypothesis is the statistical name for what it is we are trying to prove. Now, what you do in statistics is you calculate the probability of the observed data. What I did is I thought, how unlikely is it that in 10 games where I supposedly have a 50% chance of winning each time, that I would only win once? Now, I use something called the binomial probability distribution, which if you're in a statistics class you may be familiar with. And if not, it won't lose the point on you here, because the idea is that I calculated that I have about a 1% chance that such an extreme event would happen, me only winning 1 game out of 10. And now I'm ready to draw a conclusion. If the null hypothesis, the assumption that the game is fair, were true, then the sample data, the series of games I played, have illustrated an event that's very unlikely. And when we make an assumption, in this case the null hypothesis, we make an assumption and an event occurs that has a very low chance of happening if that assumption is true, that gives us reason to question the assumption. Now, could I say that there is proof that the Guess Which Hand game is rigged? No, not proof, because it is possible, mathematically possible, that in a game where I have a 50% chance of winning, allegedly, that I could only win 1 game out of 10. But that event is so unlikely, and while I don't have proof that the game is rigged, I'm going to say there is sufficient evidence to support the claim that the Guess Which Hand game is rigged. Now, this isn't the kind of problem you'd see in a statistics course, if you're indeed taking one, but this does illustrate the basic idea of what hypothesis testing is. We want to prove something, we assume to the opposite, we see if a rare event occurs based on an assumption, and if so, we conclude that that assumption must have been false, thereby proving our original point. And that completes part 1 of 7.